Good morning, Year 9s. We're going to do a little bit more practice with Pythagoras theorem today. So far we've just done some finding the hypotenuse when we know the lengths of the other sides, but we don't know the length of the hypotenuse. And today we'll do a couple more examples like that, but this time I'm going to give you some examples which don't have whole numbers as an answer. So we're going to be practicing our rounding. Okay, so the first one that we're going to have a little look at here, hopefully, is this triangle here. And the side lengths of this triangle are 3 and 5. Okay, so if we're going to be using Pythagoras theorem to find the length of the unknown side, I'm going to actually label the unknown side h, because I know that it's the hypotenuse, and h helps me to think about the hypotenuse. So we're going to go with a squared plus b squared equals c squared. That's our pattern for Pythagoras theorem. And now I'm just going to substitute in the letters for the two sides a and b and for the hypotenuse c. So I'm going to call this number here 3. I'm going to call that a, so that's 3 squared. And then I'm going to call the other one, the 5, b squared. And then our answer, well, I'll get rid of that actually. We'll call that h squared because that's how it's labelled in the triangle. All right, so because I know my times tables, I don't need to use a calculator. If you need to use a calculator, that's good. But remember, you need to be good with times tables. Will make life a lot easier. All right, so I nearly accidentally wrote a squared there, didn't I? 3 squared is 9. 5 squared is 25. That is equal to h squared. When I add together 25 and 9, I'm going to get 34. Is that right? I hope so. Now to solve this equation, we are going to take the square root of both sides. So take the square root of h squared and the square root of 34. So I'm going to go to my calculator. I'm going to type in 34 and then second function square root. My goodness, the square root of 34 is 5.83, wait for it, 095, and then a whole lot of other numbers there. Okay, so in this question, it hasn't told us how many decimal places to round our answer to. So there's a couple of options that we can do. So there's two ways that we can write the answer, I should say. The first way is to give an exact value, and that is just to keep it as the square root of 34. That is an exact value. It requires someone to enter that into their calculator, but they can find the exact value. Or we can use the approximately equal sign, and I'm going to round it to 2 decimal places. Remember, in rounding that we're going to look at the next number. If it's more than 5, we round up. If it's less than 5, we round down. Okay, so this is another example of how to find the hypotenuse. All right, so the next thing we're going to do is to use our knowledge of how to find the hypotenuse of a triangle in order to do some problems. So we've got here a problem. It's a first world problem. We've got a television screen, and you know they sell and they measure the size of a television screen is determined by its diagonal length. Okay, so the length of the diagonal, like that. Okay, so this television screen is 1.2 meters wide and 70 centimeters high. And the question is saying, please find the size of this television set, so that's the diagonal length. This is our unknown here, we'll call it x. Please find that and then round it to the nearest centimetre. So already on top of the television, the first step in solving a problem like this is to draw it as a triangle. So to take the information that you've been given and to make a geometric drawing about it. So we've got the triangle, we've got two sides which are our known sides and one side which is our unknown side, which we can use, and we can use Pythagoras theorem to solve that. So I'm just going to write here at the top. Here we've got Pythagoras theorem, a squared plus b squared equals c squared. The a and the b are these two sides here, okay, the vertical and the horizontal sides. So we've got 70 squared, well that went funny, didn't it? Plus, now 1.2 meters, these are in different units. This one's in centimeters and this one's in meters. So I'm going to change my 1.2 meters to 120 centimeters so that they're both in the same unit. Okay, so for this one I'm going to need my calculator. Let's have a look. 70 squared is 4,900 plus 120 squared, 14400 equals our hypotenuse squared. All right, so now we're going to add those two together. There's that number 14,400. We're going to add to it 4900, 19300 equals c squared. Now we're up to solving the equation, and we remember when we're solving an equation we do the same thing to both sides. The thing which needs to be done to both sides is to take the square root. Okay, now the reason for this is that the square root of c squared is c, and the square root of 1930 is something that I can't do in my head, of course. So we're going to use that. Now, it says round it to the nearest centimetre. So if I just write this down as 138 point, let's remember again, 138.924, etc. But we now need to round it just to the nearest centimetre. So when we're rounding, we look at the next digit, okay? So it's already in centimetres. We don't want any decimal places, so we want 0 decimal places. So we look at the next figure, we look at this one, it's the number 9. Is the number 9 greater than 5? Yes, it is. That means we need to round this up. Okay, so it will be rounded up to 139 centimetres is the width or the size of the television screen. So that's the diagonal length. So there's my pointers for you. When you're given a problem, you're given some information. First step is to change it into a diagram. See what information that you already have and see what it is that you have to find out.